Okay guys, here we go with our simplifying radical expressions video. I'm going to get going on this because it's going to take a little bit of time to go through this. We got a lot to go through and an answer. Okay, with our first one, example 1, approximating square roots. When we approximate, guys, all I want you to do for this one is to find that the whole numbers that is between and then graph your answer. So if we're going to approximate the square root of 51, we first have to think about what perfect squares is 51 between, and that would be the square root of 49 and the square root of 64. Because the square root of 49 is 7, the square root of 64 is 8. So our answer of the square root of 51 is between 7 and 8. Okay, now I want you to graph that. So I'm just going to make a quick little graph. 6, 7, 8, 9. Now I want you to graph where that would be, and I want you to approximate which ones it's going to be closer to. Since 51 is really close to 49 and a little farther away from 64, I'm going to put my point closer to 7, really close to 7, because when I approximate, it's going to be just beyond 7. And so where you place it on your number line is important to me, not just anywhere in there, but it's got to be kind of approximated towards one side, middle, or the other side. Okay, square root of 95, that's going to be between the square root of 81 and the square root of 100. So this one's going to be between 9 and 10. Again, I'm going to make a quick little number line. We'll do 8, 9, 10, and 11. Now when I place this one, again, I'm going to look. 95 is 14 away from 81. It's only 5 away from 100, so it's much closer to 10 than 9. So I'm going to put it over in there somewhere. You know, it's kind of near, probably a little bit between half and to the 10 there. So it's close, definitely closer to the 10. So when I look for your answers, I am looking for not only the number answer between the two digits, whole numbers, but also how you're going to graph them. Okay, I'm going to move on to our next slide. If you need to pause, go ahead and pause. All right, there's nothing to write, nothing that I'm going to write down here, so just make sure you pause this when I'm done talking if you're not done. This is the product property of square roots. And basically, if we have a number, we can break it up into its different products to answer and simplify our radical expression. So for example, if I have the square root of a times b, then I can say that that is also the square root of a times the square root of b. What does that mean for numbers? Well, let's say we have the square root of 63. That's what 9 times 7 is. So 63 is, the square root of 63 could be also the square root of 9 times 7, which means I could break that into individual square roots as the square root of 9 times the square root of 7. I cannot do the square root of 7, however, I do know that the square root of 9 is 3, so that's where my 9 becomes the 3, and then that remains the same. So my final answer would be 3 to the square root of 7. So that's what we are going to be doing with numbers. So prior to this, I was telling you to leave them as is. Now we're going to take it to the next step. So if you need to go ahead and pause and write that down, you can. Otherwise, I will be moving on to our next page. All right, let's solve them in our next page here. So now I want to simplify radical expressions, so now we're going to do them. So now I have to think about what perfect squares. I do not want to use 1, guys, in my perfect squares. That doesn't help me. 1 times 32 doesn't help me. So I want to use other numbers besides 1 that multiply to go there, and I want to use the greatest numbers that I can think of. Okay, so I can say like, oh, 2 times 16. That does, work. 2 is not a perfect square, but 16 is. So there we go. So I'm going to do the square root of 16 times the square root of 2. Now I'm going to separate them. You could write the intermediate step of saying that 32 is 16 times 2, but I want to see for your work, I want to see you write it down separately, but so that the two numbers that you have here, or 3 or 4 I guess you could go on, would equal 32. Really there should be 2 numbers there. Square root of 16 is 4. Square root of 2 I cannot do, so I get the square root of 4 times 2, and that's as simplified as I can make them. Alright? So going through these, again, you may want to have your list out of your perfect squares so you can find perfect squares that multiply that go into it. Okay, using a perfect square does not go into it, does not help us. So an example B, using the perfect square 9 does not help us. So remember our perfect squares are 1, 4, 9, 16. Our next one's 25, 36. You're not going to have too many bigger numbers, but you could. But as you're going through there, these are the numbers you want to be trying to go see what they go into 20. Again, we're not going to use 1 because that does not help us. Okay, 4 does, 9 does not, 16 times nothing, okay, 25 times nothing. It's always multiplication, not adding. So 4 is the only one in the list, and then beyond 20, that goes into it. So 4 times what? 4 times 5. So I'm going to break this into the square root of 4 times the square root of 5. The square root of 4 is 2. Square root of 5, we don't know, so I'm going to leave that as the square root of 5, and I get 2 to the square root of 5. So it's really important that you have this list, especially if I give you a larger number like square root of 180, you can write this down or not. Okay, when I'm going through my list, okay, does 4 go into it? Yes, 4 does go into it, so I could use 4. Does 9 go into it? Yeah, 9 times 20, that goes into it. I keep going down, I eventually can figure out, oh, 36 goes into it, and I want to use the biggest number, so I'd use the square root of 36 times the square root of 5. So even though 4 and 9 would go into 180, I want to try to find the largest number I can. Otherwise, you could still get the same answer, okay? That would be then 6 to the square root of 5. If I used 4 and I used 9, I would use both of them. They still would have both worked. That would have been 2 times 3. There's my 6. So it's easier to find the largest one. So you want to have this list written, and maybe you want to start from the biggest numbers and work your way down, because the biggest number that you can find that goes into it, that is the number that you want to use. Okay, I'm going to go on to my next slide. If you need to pause, go ahead. All right, in my next slide, we are going to have, too many slides, I'm sorry. I got to slide down, that's not the right spot. There we go. Example 3, we're going to do the same thing with variable expressions. Variables are actually fairly easy because they are already exponents with us. So we want to just look for groups of 2, because if it's squared, I can break them into series of squares. So these are really easy. I can just break them into series of squares. So for 24, again, I'm going to think about my list. Okay, 4 times 6. That's what I'm going to use. All right, so I'm going to do the square root of 4 times the square root of 6 times the square root of x squared. So now I'm going to introduce that third section because I have a variable. Square root of 4 is 2. Square root of 6, I don't know. And then times, and the square root of x squared is just x. Now I want to combine this and make it look nice and neat. I go whole numbers, variables, radicals. That's the order I'm going to do it in. So whole numbers, variables, radicals. So my answer is 2x to the square root of 6. Okay. For B, I have 18x to the third power. So again, I'm going to go through my list. 1, I'm not going to use. 4 does not go into 18. 9 does. So I'm going to do the square root of 9 times the square root of 2. Now I'm going to break this into a series of 2. There's my 18, and then I'm going to do my x. I'm going to do x squared times the square root of x. And that's how I'm going to get that answer. Now I'm just going to go through and do these. That's 3. I don't know this one. This is just x, and I don't know that one. So now I'm going to combine them. And when I put them back together, I'm going to go whole number, variables, and then my radicals in the same order. 2, and then I can recombine the x. 2x. Okay, so my final answer, I always go whole number, variable, and then radical, and in the radicals I follow the same thing, whole number, variables. All right, and that's how I answer those. Okay, I'm going to move on to my next slide. If you need to pause, go ahead. All right, in my next slide, okay, what happens if I have a fraction? Not too hard if I have a fraction. I'm going to follow the same rules that I have been following, except this time I can break the numerator and denominator up. So this is really just the square root of 5 over the square root of, the square root of 25 over the square root of 49. Now when I answer this problem, that is 5 over 7. And there's my answer. So I can do them individually. With B, I can follow the same thing. This is the square root of 32 over the square root of n squared. Now I got to break up that square root of 32. I've already done this. What goes into it? 4? No, yeah, 4 does. Okay, let's see if there's any bigger ones besides 4. Okay, 4 goes into it. 9, no. 16, 16 does. 25 does not. So I want to use 16. So it's going to be the square root of 16 times the square root of 2. Okay, and then that's going to be over the square root of n squared. Now I'm going to do my work for my final answer. Square root of 16 is 4. Square root of 2 is the square root of 2 over n squared is n. Okay, so you're basically breaking them into individual problems, doing the work, and then just kind of pushing them all together for your final answer. Okay. Again, if you did 4 and then you said 4 and 8, remember 8 could then be 4 and 2 again. So you really want to make sure that the number that's remaining cannot be. You want to use the largest number possible. All right. That is our lesson for tonight. We will definitely be working on a lot of examples in these in class tomorrow. I know you guys may have some questions, but we'll go over them tomorrow. But really just breaking them down into simpler problems and then re-putting them together. Have a good night, and I will talk to you guys tomorrow.